Alright, so now we are on to the part where we will create our closing price predictions. And just like with any other sections we have previously covered, we need to make sure that everything is installed correctly. So there are a couple things we are going to need. We are going to need to have analysis services set up. So during the installation process of SSMS, you want to make sure that this option is selected as well. The next thing you want to have is Visual Studios, and make sure you have SSAS included with Visual Studios as well. You also have the options for SSIS and SSRS. I would also check those options. Having everything set up properly wasn't really that much of a hassle for me. I've worked with SSAS before in SSMS and in Visual Studios, so most of this was already set up. So with the analysis services, we are able to create a cube database as well as write DMX queries. DMX stands for data mining expression, and the main goal of this for us in our case is going to predict the final closing price. Now we make the predictions using SSAS and Visual Studios, but when we come to the analysis services in SSMS, we are able to predict a longer time period for what we are trying to predict, and that is the closing stock price. So we have a cube database called stock prediction closing price. And this is basically the store procedure where we grabbed our machine learning data from. And to try and explain what a cube is basically sort of like a cube, like the name itself is. But with this in a data warehouse or a database settings, you have totals pre-calculated. So any total you want to look at, it comes pre-calculated. So you don't really have to write out any SQL, or the computer doesn't have to go through any calculations. Like, let's say I wanted to look at the average closing price for a particular stock symbol. That should be already pre-calculated if I'm not mistaken with the cube. Whereas where you write it in a relational database using T-SQL, the computer has to go, or SQL has to go through calculations. But our main goal is to try and retrieve stock closing price predictions from our SSAS mining model. So this right here is the final product of when you've created your predictions using SSAS in Visual Studios. You could come here to the analysis services and run predictions at a 7-day period, 2-week period, and all the way up to a year. I don't think there's any limitations. And this is the DMX I've created. Although I've created predictions in SSAS and Visual Studios, we've never gotten this far to this part where we actually predicted a longer time period, or actually came to the analysis services and wrote a DMX like this. So again, some of this stuff was new to me, but wasn't really too hard to figure out. So you can see here that I actually ran this process all the way back in July. So I believe it was maybe July 9th is when we finished our predictions, and I had the model predict up to a 7-day period. But we are going to run an example where we predict for a full year. I don't think we need to process our mining model again. You could basically, in the part where it says predict time series close, comma 7, you could change that out with whatever number you want, and that will represent the days. So if I put 360, we are going to get a full year. So the query is executing, and you are going to see the stock symbols for each one run up all the way up to a full year. So before we had it at a full week period, but now you can see we are in the year of 2021. And with this DMX query, we are also able to use it in Power BI. So we could connect to our analysis service engine and then have this query ran, and we will get the same results, and we could visualize that data in Power BI as well. But I'll show you the steps it took to actually get to this ending point. So we are in Visual Studios right now, and I do want to mention that before coming to Visual Studios, I tried to create predictions using Python, but I wasn't able to successfully do it. But then I remember that I actually created something predictions similar to this when I was back in school. So I thought Visual Studios would be a good alternative option. It was probably the best option in the end as well. Although I use Python for different algorithms, the algorithm I was looking to use, which is the ARIMA model, I wasn't too familiar with that one. So there's a lot of variables you can put in functions. A lot of things have to be correctly done in order to even get it to work. And especially since I'm dealing with a huge data set, a lot of things could go wrong and I may not understand the code to its fullest. So coming to Visual Studios and using SSAS was a little bit more up my alley. Okay, so our solution or project has finally opened. And you can see the first thing we are greeted with is a data source view. Whenever you start a new project using Visual Studios in connection with SSRS, SSAS, and even SSIS, you are going to need to connect to a data source. Our data source in our case is a database which we have seen before, and it's called stock test. Then from that data source, you need to create a data source view. This is basically what you want to pull from your data source. So our data source view is going to allow us to only retrieve specific information. So when we run our algorithms, we are not including information that is not useful to us. So you can see in our data source view, the only thing we have is our store procedure, which was called the machine learning data. But I could quickly go through and show you what adding and removing tables look like. So all you would have to do is just right click on the empty pane and it'll give you a list of options. You could write a query, you could add tables, create a new relationship for the tables you already have in your data source view as well. So you can see once we click the option to add or remove tables, we are greeted with a list of tables and even store procedures as well, or views, excuse me. I know I called machine learning data a store procedure, but excuse me, it's actually a view. So that is our only table in the data source view. So now that we have that, we can create a new mining structure. So a mining structure is basically what type of algorithm you want to run. And thankfully with Visual Studios, they give you a graphical interface of the different types of models you can run, how to set it up, and more options as well. So the first thing we have, they ask you, do you want to choose from a relational database or a data warehouse? Then they ask you which data mining technique do you want to use. So these are the different algorithms you can use. Some of these algorithms I worked with in Python, but some of them I haven't. So the algorithm or the data mining technique we want to use is Microsoft time series. Logistic regression was my initial thought way back then, but then after some research, time series seemed to be the better one. And you can see from the description, it tells you that any data that is time related, such as sales data or yearly profits, is best for this data mining technique. Quickly moving through the steps, you can see our data source view, and it is called machine learning data. So we've already went over that. And we are going to select that view as our case. And then from here, we could select all the columns we want. We could also declare which column would be an input and which column would be the predicted value. So the input is basically like the independent variable, what we are plugging in effect to the result of the dependent variable. So basically all the columns here except the close column will be our input. It's a reason why we have this view created. So the close column will be the predictable, and then you also need to specify a key. The key in my case was the stock symbol and the date. And on top of that, Visual Studios or the data mining wizard, can also help you suggest which columns are most influential on what you're trying to predict. So once you have your dependent variable selected, it'll give you a suggestion on which columns are most influential on that dependent variable or what you're trying to predict. So right now for me it took a little too long to run, so I didn't end up running it actually, but you can see it gives you the column name, the score of it from greatest to lowest, and then it gives you the input column, whether it should be an input or not. The first time I ran it, it didn't take too long, but for some strange reason, when I tried to run it again while I was recording this, it was just taking forever to run. It's only going to sample the data, but it was sampling too much data, I guess, and so it never actually produced any results. But that was fine with me because I wanted to use all of the columns that we had from that view. And there are certain ways you go about picking columns whenever you're going to run different types of algorithms. It's not really just one straight shot and you pick all the columns. There's a method behind it, but in my case, I really knew what columns I wanted to choose, no matter if I did the research behind them first. This is just for demonstration purposes and wanted to see if putting different things together would create a useful algorithm. But in most cases, you would not do what I do. You would actually go a little bit further and do a bit more research to see if the columns are highly correlated, or look at a correlation matrix plot as well. Okay, and after that step, you get taken to this page here where you can specify the content type of the column and the data type of the column as well. So continuous means that the number is basically like a decimal, like 1.01 or 1.35, basically values like that. Discrete would mean that the value, I believe, is like a whole number, but then again, you could have it be a data type of a text, and that's what we had with our sector name column. So after that last step, you could go on and process your minor model. But I want to show you what our predictions look like before we go over that process. So these predictions are from the last time I ran this minor model. And when we run it again, I don't really expect it to be any different. Maybe slight variations here or there, but for the most part, it should be the same. So you can see here, we have the minor legend. And then you can see in the background, we have our predictions. So initially, if you do not make any changes, you are going to have all of these stock symbols listed here. So just for demonstration purposes, I removed a lot of them and only selected a few. But you can see these are our predictions, but we want to predict a further time period. In addition to that, we also want to retrieve those predictions and use it in some type of report as well. So let's actually get back to our minor model and process the model that we have. So before we do that, we need to set some parameters for our algorithm or minor model. And you can see that Visual Studios within SSAS give you a wide range of parameters to enter. Now these parameters are based on the algorithm you chose, so different algorithms will have different parameters. So these parameters already have default values listed, but if you come to the screen, you can set up and override those default values. So one or a couple parameters I want to look at is the forecast method. So you can see our forecast method is set to fixed, and for me in my case, I was perfectly fine for that. The parameters also come with a description, so if you aren't too sure what the parameter name means, it'll tell you what that parameter exactly does. So another parameter I want to look at is called the missing value substitution. What this is that if there are any gaps in our data set, meaning that let's say we have a record on January 1st of 2020, and then our next record, doesn't occur until January 20th. How do we want to handle that process? Do we want to use the previous record for all the missing gaps or the missing days between that time frame, or do we want to use the mean between those two values? A lot of the times each situation is going to be different, and you just pretty much have to use logic on how you want to attack it. In my case, since we are dealing with stock data, and because the values aren't going to be different, real different from one day to another, I think using the previous method was the best way to go. So to override the default value in the value column for that specific parameter, you just have to type in what argument you want or what value you want for it. This was basically the main parameter for me. Other than that, I left everything else pretty much on its default setting. So after we have fine-tuned all our parameters and everything looks ready to go, we can finally go and process our data mining technique, or our algorithm in this case. So once you click the recycle or process button, you can then run your algorithm and it'll start to run. So when we click run, it'll show you the process progress screen. So this was the biggest thing for me, because when I try to do this in Python, I wasn't too sure of the progress of the algorithm when I use Python. But here I have a screen, I can see what stock symbol the model is on, exactly what the model is doing, and it's going to tell me everything. And because this process takes quite some time, using Python, I don't know how long, or I can't see if the model is actually doing something or not. So this was a good screen to have, and it allows me to see exactly where we are. So this process actually takes around 3.5 hours to complete. So you can see by the time on the screen, I ran this pretty late into the night or pretty early in the morning at around 2 o'clock a.m. And I just decided to let the algorithm run, left my computer, came back and by the morning time, and everything was done. So this is the second time I've actually ran this model. And because it takes a long time, and also because we have the predictions, you basically only need to run it once. But in this video series, at the end of it, I will add more stock symbols and show you how everything is automatic and how it works. But for this part, I would need to come in manually and do it myself if I want to have those predictions for those new stock symbols. And again, these predictions aren't perfect. This is just for demonstration purposes. So I really wouldn't use these as a huge influencer as when it comes time for me to pick the stocks I want to purchase. And another thing I want to know here is that I'm by far no expert when it comes to processing mining structures in SSAS using Visual Studios, and I'm pretty sure there are methods to decrease the runtime for this mining structure. But the purpose for this was to basically show a demonstration of how I was able to put everything together, or narrowing it down a bit, creating predictions for a stock symbol. So now the whole process is finished. So you can see that we started at 1:47 a.m. and it did not end until 5:34. So over 3.5 hours, very well close to 4 hours for this whole process to be completed. And with that, we can view our predictions that have been created, which we've already seen before, but we could take a look at it again. And you can see the second time that I ran this mining structure that we had a bit of an issue, but fortunately I was able to figure what was wrong. And whenever anything goes wrong, I always come to the configuration manager to see if anything has stopped. And so this was the case here. After I enabled the SQL Server agent for the tabular engine or the tabular database, everything seemed to work fine. And that's another big lesson with this project. When you have all the steps and everything planned out, there's going to be problems along the road, and it's really all about figuring out what is causing the problems and how to fix it as well. So before, when I was trying to get the predictions on this page in the mining model viewer, I wasn't able to because the query was taking too long to send to the server. and I would get a connection timeout. But after we did that, we are now able to get the predictions visually within Visual Studios at this point. So now it's working, and it took a little bit of time to run or send the query to the server. It took about 2 to 3 minutes, but now you can see we have our predictions again. So after we have completed that, we could go back to SSMS and access our analysis services, and we could log in easily. So this is the server name and the server type I use for whenever I log in. So this whole database is not online, it's only on my computer, so I don't really think anyone else could log in. So something I didn't show you before the first time we looked at this screen is that we have our data sources and our data source view. You can create this in SSMS as well, and on top of that you could create it in Visual Studios. But you can see we have our mining structures as well, and you can see we have our mining structure called machine learning data. So now that we have that, we can run that DMX query we had before. So before, if you go back to the earlier portion of the video where I first showed you the screen, you can see our predictions started in July. But now when we run the DMX again, our predictions are from December 25th all the way up to next year, December 25th. And because we have this information, I could then use it in Power BI to have a graph that shows the prediction of those prices over a period of time.